Okay, so as you're settling in, remember last time we were looking at systems of equations, and we started by graphing. So we might have an equation like y equals 2/3 x minus 1, and another equation, stick with me guys, y equals negative 1/2 x plus 6 should work. Then we had to graph both of those equations. So for this first one here, the top one, where do I start when I graph that? So this top one, where is our y-intercept? Where do we start at? -1, very good. We start right there. 1 unit down from the origin. From there, of course, the number multiplying x tells us what to do. So what are we going to do from here?
Go up 2 and over 3.
Up 2 and over 3. There's our second point. I might do it another time. Up 2 over 3. My line goes through those points. The second equation here, where are we going to start with that one? 6 is the number that's added or subtracted. It's added on. So we start out at 6, and from there we're going to go
Down 1 and over 2.
perfect. A slope of -1/2 means we go down for our rise, down 1, and then, yes, over 2. Now I'm going to do that again, down 1, over 2, down 1, over 2. And as long as we're careful with our graphing, we can get to the point where those lines cross. Now remember, what we're looking for here is the point, the values for x and y that make both equations true. You know, the blue line here was all the points that make this top equation true. And the purple line is all the points that make this bottom equation true. So where they cross, that one point, if they do cross in one point, is the spot that makes both of them true. So that point there is going to be 6, 3, it looks like. Now to be sure, we should go back and test that because our lines on our graph could be slightly off, slightly sloppy. So to test it, we go back to both equations and we try 6 and 3 for values of x and y. So let's do the top equation first here. What's going to go in for y?
3.
The 3, good. So 3 equals 2/3 times, and then for x we put in 6, then -1. And now we do our order of operations. There's nothing to do on the left side. On the right side we're going to do 2/3 times 6, which is 4. Perfect. And 4 minus 1 is 3. Very good. Well, 3 does equal 3, so that is true. Let's look at the second one here now. So we put in 3 for y again. -1/2 times for x, we put in 6 again. Plus 6. So again, nothing to do with the 3. -1/2 times 6 is -3. And -3 plus 6 is 3. Perfect. So 3 equals 3. So it does make both of those equations true. So that is a solution to that system of equations. Now we ran into some other possibilities. We might have something like this, 3x plus 2y equals 4. And y equals negative 3 halves x plus 2. We go to graph these. Well, let's do this bottom one. That one's ready to graph. Where am I going to start with that one? Positive 2. And from there, what am I going to do? Yeah, we got negative 3 halves slope. So we're down 3 and over 2. So there's where our second point is. So our line goes through those points. Now this first equation then has to be rearranged so that we can graph it. And this is the tricky part. Remember, we're used to solving for x, but here we have to solve for y. We have to get y by itself. So we have to get rid of the 2 and we have to get rid of the 3x. What do we do first?
Subtract the 3x.
Perfect. We subtract the 3x. So we've got 2y equals 4 minus 3x. And then
Divided by 2.
we divide by, perfect, we divide by 2 on both sides. And when we divide, we have to divide each digit in the whole equation. So the 2's divide out, leaving us y. 4 divided by 2?
2.
2. Negative 3x divided by 2.
Negative 3 over 2x.
Negative 3 over 2x. So where does that one start at?
Positive 2.
Positive 2, and from there it goes
Down 3 over 2.
down 3 over 2. And since those points both lie on this line, we find that those two equations, those two lines lie on top of each other. If the lines are on top of each other, that means they're the same line, which means this system of equations has an infinite number of solutions. And the solutions are just all the points that are on either line. So to express that solution, all I have to do is write down either equation. So I'm just going to write down the second equation. Y equals negative 3 halves x plus 2 is the solution. Any point on that line will also be on the other line since they're the same line. We might have this system of equations. If we go to graph this one, both of these have to be solved. So let's start with this top equation. 7x plus 3y equals 9. What am I going to do to start here? We subtract 7x. And again, when we add or subtract from an equation, we just have to take from one digit on each side, right? So the 7x cancels out. I have 3y here. 9 minus 7x is 9 minus 7x. And what's next?
Divide by 3.
Divide by the 3. So the 3 cancels out there. We've got y equals 9 divided by 3?
3.
3 and negative 7x divided by 3?
Negative 7/3 x.
Negative 7/3 x. Okay, so when we go to graph that, where do we start?
3 positive.
Positive 3, and from there we go
Down 7 and over 3.
down 7 and over 3. So there's that graph. Now let's do the second equation. Where do we... Okay, perfect. We start by subtracting the 2x. Very good. So it's 5y equals 15 minus 2x. Then what?
Divide by 5.
We divide by 5. So y here, what's 15 divided by 5?
3.
3, and negative 2x divided by 5?
Negative 2 fifths x.
Perfect, negative 2/5 x. So where do we start?
3.
3, and from there we go
Down 2 and over 5.
down 2 and over 5. So what's the point there where those two lines cross? Well, the x-coordinate is 0, and the y-coordinate is just the 3. So the solution there is 0, 3. Now, I'm not going to take the time to plug it back in and double check it here, but you can plug it back into both equations and make sure that x is 0 and y is 3 makes both of those equations true. We might have x plus 3y equals 6, and y equals negative 1/3 x minus 1. So if we go to graph this one, let's start with that top equation. We're going to have to do a little work on this one. What do we have to do here? Subtract x from both sides. So 3y equals 6 minus x. Then what? Divide by the 3. So y equals, what's 6 divided by 3? 2. And negative x divided by 3?
Negative 1/3 x.
Perfect, negative 1/3 x. We treat that as a negative 1x. So we put negative 1 over 3 as negative 1/3 x. So where do we start?
2.
We start at positive 2, and from there we go
Down 1 over 3.
down 1 over 3. Perfect. Okay, the second equation is already solved, so where do we start there? At negative 1, and from there we go
Down 1 over 3.
down 1 and over 3. Where do these lines cross? They don't. They have the same slope. They both have a slope of negative 1/3. And if they have the same slope, we went over this a couple weeks ago, that means they are parallel. If they are parallel, they will not intersect. So there is no solution to this system. There is no point at all where these two lines will ever cross. So now let's do a little bit of review of graphing single lines for a second. How would I graph y equals 7?
You go 0, 7.
Okay, yep. At 0, 7, there's a point there. Think of it, I can think of this like this. Y equals 0 times x plus 7. Because 0 times x is 0, right? So that's telling me is, yes, the y-intercept is 7 and the slope is 0. So I don't ever go up, I just go over. So I get a flat line like that. And on the graph, a flat line will have a slope of 0. So if I wanted to graph y equals negative 2, where's that going to be? Yep, we go down 2, 0, negative 2, and yes, it's going to be a flat line at negative 2. So that makes sense. We have a slope of 0, and we have, y-intercept of whatever that number is. This does not quite fit in. How about if we have x equals 3? Okay, yep, 3, 0 is going to be that point. And in fact, perfect. Good job. It goes up and down. So x equals 3 is a vertical line. at x equals 3. It goes through the x-axis at 3, and it's vertical. What would the slope of that line be? Yeah, it does not exist. It's considered, sometimes it's called undefined. I'll show you a little way of remembering that in just a minute. So then, of course, x equals -5 would be where?
5, 0, and then that would go up and down.
Perfect. At -5, 0, and up or down from there. And again, that has a slope that does not exist. To remember, we know that one of those is a slope of 0, and the other one is an undefined slope or a slope that doesn't exist. To remember that, this is what I do. I picture skiing. So we're going to send me downhill skiing. So if I am skiing and I'm on a slope that's like this, is that much fun? Yeah, maybe. That's a little bit of fun. That equals a small slope. Small slope, little fun, right? If I'm on a hill that's like this, is that much fun? Yeah, that's greater fun. So that's a greater slope. If I am on a hill that looks like this, is that much fun? No, that is no fun. In fact, I'm going to define it like this. That is 0 fun. So that has 0 slope. So then if I'm on a hill that looks like this, that would be a cliff. What happens to me if I ski off a hill that looks like that? I no longer exist. So that slope does not exist. Okay. So I want to look now at systems of equations that involve those x equals or y equals equations. So we might have 2x minus 3y equals 9. And y equals, oops, that's not what I wanted. Y equals -1. So I need to graph each of those equations. Let's start out with that top equation. I have to rearrange it. I have to solve for y. So 2x minus 3y equals 1. What do I have to do first? Subtract 2x. So 2x is gone. I have -3y equals 9 minus 2x. What's next? Divide by -3. There we go. So the -3 cancels out. Y equals perfect. 9 divided by -3 is a -3. -2x divided by -3. Negative divided by negative is a positive. And again, we just put the 2 over 3 to make 2/3 x. So when we go to graph that, where do we start? -3, and from there we go up to and over 3. Okay, then we need to graph the y equals -1. What's that look like? First of all, is it going to be a horizontal line or a vertical line?
Vertical.
Careful.
Horizontal.
It's going to be horizontal. It's going to be a flat line. And it's going to go through -1. So that's right here. On the y-axis, it's -1. It's going to look like that. So the solution to this system is where they cross. That's at the point 3, -1. Now, a way to double check that one is we know that y has to be -1 because the only points on this line have coordinates of y equals -1. So that helps that y is -1, so we can test in the other equation to see if x equals 3 makes that equation true. I would put, oops, right here, 2 times x is 2 times 3, minus 3 times y, so it would be -3 times -1, equals 9. 2 times 3 is 6. Now I can treat this as either a -3 times -1 or a minus 3 times -1, which is -3. 6 minus a -3 becomes 6 plus 3 is 9. So that is true. We might have (2x minus y equals 5). And we might have x equals 2. So we go to graph this. Our top equation here, we're going to solve it for y. Where do we start? We subtract the 2x. Good. So -y equals 5 minus 2x. Then what? Okay, yeah, that's -1 times y, so we divide by a -1. So we've got y equals, what's 5 divided by -1? -5, and -2x divided by -1? Positive 2 over 1x, or just positive 2x, either way. So we start that out at -5, and from there we go up 2 over 1. So I've got my graph. This one, x equals 2, where does that go? Vertical, up and down, perfect. And so those lines intersect at perfect. We know that x has to equal 2, and we can see there that y equals -1. Nope, that's positive 2. 1 and 2 going the positive way. This is the -1 here. Okay, now we also looked on Wednesday, we started looking at algebraic methods. So we might have equations like (2x minus 3y equals 9) and 3x plus y equals 8. And when we had, the method we talked about on Wednesday was substitution. Substitution involves us to either know one of the equations has to be in the form of either y equals or x equals. And in this case, neither one of them are in that form. So we have to figure out if we can turn one of them into that form. So in order to do that, we look for ones that have no coefficient on the variable. So no coefficient on x or y. Do we have an equation here that has either x or y with no number in front of it?
Yes.
Yes, the second one here. That's just a y there. There's no number in front of it. So that one would be easy to solve for y. How would I solve that one for y? I would subtract the 3x. Good. So y equals 8 minus 3x. So now that is, this equation right here is being replaced with that one that I just solved. So now we know that the y value in this equation has to equal the y value in the first equation, at least at the point where the solution to this system exists. So I put y in there. What I'm going to do is I'm going to rewrite that first equation, I should say. 2x doesn't change, minus 3. Instead of y, I'm going to put in 8 minus 3x equals 9. So all I have done here is I've replaced this y with this y. And that y equals 8 minus 3x. So I put that in here. So now it's just a matter of solving this equation, and we'll get a value, we'll get a number for x. You see that there's parentheses here, which tell us we have to do something there first. Is there anything to do inside of these parentheses?
Yeah. You can multiply
Yeah. You're right. We can't combine anything inside, but we do have to multiply by the negative 3. Perfect. So our 2x here is not going to change. We have negative 3 times 8 is negative 24. Negative 3 times a negative 3x? Positive 9x. And that equals 9. So our next step, there's more than one x in this problem, so we're going to have to combine. Can we just combine them, or do we have to take one away?
You can combine them.
They're on the same side of the equal sign, so we can just combine them. So we've got 2x and 9x make 11x. We still have the negative 24 equals 9. What's next? Careful. We have to add the 24. We're solving for x again now. So add 24. So 11x equals 33. And then divide by 11. So x equals 3. Now that we know that x equals 3 is part of our solution, how do we find y? Perfect. We put x equals 3. We put 3 in for x in one of the original equations. Or we can use this one, which is just one of the originals that we solved for y. And I'm going to use this one because being in that form y equals 8 minus 3x is going to make it easier to solve. I'm just going to replace the x here with 3. So y equals 8 minus 3 times 3. What's the first thing we have to do over here on the right? Yeah, we have to multiply. So the 8 doesn't change. Negative 3 times 3 is negative 9. And then subtract. 8 minus 9 is negative 1. So we've got x equals 3, y equals negative 1. And we should write that as an ordered pair. 3, negative 1. Make sure you put the x first. Okay, so we sometimes run into ugly equations, ugly systems like this one. We need to solve one of the equations for a variable, but none of the variables here have no coefficient. All the variables are multiplied by a number of some sort. So we have to look for ones that would be easy to solve for. I'm going to go piece by piece here. What I want to try to solve for the x in this equation. Well, no, that has a coefficient of 3 on it. And when I divide by 3, I get repeating decimals. Now I get 0.33333 or 0.66666. Now that doesn't mean I don't want to, there may be still a chance that I want to solve that for x if every other number in that equation is divisible by 3. However, is 7 divisible by 3? No, and 38 is not either. So I don't want to solve that for x. Well, how about solving for y in that equation? Well, dividing by 7 gives us really ugly decimals as well. 0.14285714 or whatever. But again, I may still want to divide that one if everything else in the equation is divisible by 7. Well, in this second equation, is everything else divisible by 7? No. So the bottom equation is out. We're not going to solve that for either variable. So now in our top equation, we have the 2 on the x. If I divide by 2, do I get ugly decimals? I might get decimals, but it's either going to be a whole number or it's going to be 0.5. So that's a possibility. I have the 5 on the y. If I divide by 5, again, I might get decimals, but it'll either be 0.2, 0.4, 0.6, 0.8. So they don't repeat. So at least I'll get a 1-digit or a simple decimal. So trying to decide between solving for x by dividing by 2 or solving for y, which would be dividing by 5, which one do I want to do? Well, I ask myself, does everything in this equation divide by 2? Nope. Does everything divide by 5? Nope. So it really doesn't matter whether I solve for x or y here. Because I solved the last one for y, this one I'm going to solve for x. So to solve this top equation for x, I'm going to get x by itself. So to solve it, I'm going to subtract the 5y. So that's gone. I have 2x equals 27 minus 5y is 27 minus 5y. What do I have to do next? Divide by 2. So x equals 27 divided by 2 is 13.5. Negative 5y divided by 2. Well, normally I'd make this negative 5 over 2, but since I'm going to put it into another equation, I'm going to make that a negative 2.5y. So that is, remember, that's the first equation that I solved. It's important that I remember that because now I have to put it into the other equation. And I'm going to replace x because this is x equals. So I'm going to rewrite this second equation. Instead of 3x, it's going to be 3 times 13.5 minus 2.5y. I still have the plus 7y equals 38. Now I have that parentheses, so I got to multiply by 3. 3 times 13.5 is 40. Perfect, 40.5. 3 times negative 2.5y. Negative 7.5y. I still have the plus 7y equals 38. So now I have the negative 7.5y and the positive 7y. They're both on the same side of the equation. If If I combine those, what do I get? I get a negative 0.5y. So 40.5 minus 0.5y equals 38. Now what? I have to subtract the 40.5. So that leaves me with negative 0.5y. 38 minus 40.5. Negative 2.5. Good. And my last step is going to be to... Perfect. Divide by a negative 0.5. This gives me that y equals... Negative divided by negative is a positive, and 2.5 divided by 0.5 is 5. So y equals 5. Now I'm going to bring that up to this equation right here to find x. X equals 13.5 minus 2.5 times y. Well, I'm going to replace y with 5. So this is x equals 13.5 minus, what's 2.5 times 5? 12.5, good. And then 13.5 minus 12.5. Careful. 1. There we go. So then we should make sure we write our answer as x first is 1 and then y is 5. So 1, 5 is our solution. Now just like with graphing, we can run into complications with solving these equations with substitution. We might have 2x minus 3y equals 9. And we might have 6x equals 4y plus 1. Now looking at these, I have two equations here. Which equation am I going to want to solve and for which variable? I don't want to solve for the y here because I'd be dividing by 3. I don't want to do that. 6, I don't want to solve. I don't want to divide by 6. I'm not going to solve for x in this one because that 6 would leave me with ugly fractions. Solve the top one for x. That sounds about right. Usually it's easiest if 2's are about the easiest one to divide by if we have to divide. So we've got 2x minus 3y equals 9. What's our first step to solve that for x? Add 3y. Since it's a negative 3y, we're going to add 3y to get rid of it. So 2x equals 9 plus 3y. Then what? Divide by 2. And again, instead of leaving our division as fractions, we're going to divide them into decimals so that we can use them to substitute back in. 9 divided by 2? 4.5 or 4.5, good. 3y divided by 2? 1.5y. So now that came from this top equation, so we have to put it back into the bottom equation. So 6 times x becomes 6 times perfect. 4.5 plus 1.5y equals 4x plus 1. So we're going to do 6 times 4.5, which is 27. 6 times 1.5y. 9y, okay, and we still have 4x plus 1. Then what? Oops. I screwed up. I had x in there multiple times, didn't I? We're going to have to step back a step here. Now I'm going to have to give you the appropriate equation here so it actually works. This one should have been 6y equals 4x plus 1. Sorry about that. So we solved the top equation for x. We're plugging back in, only x is here, not over here. So that's going to be 6y equals 4 times, instead of x, we're going to put in the 4.5 plus 1.5y plus 1. That'll make more sense. Sorry about that. So now the 6y doesn't change. What do we do on the right side? Distribute the 4. Good. 4 times 4.5 is 18. 4 times 1.5y? 6y. So now before we do anything else, we should combine what we can combine on the right side here. We've got the 18 and the 1 make 19. Good. So we've got 6y equals 6y plus 19. We have y on each side here. We have to get rid of one of them. Normally, we would get rid of the smaller one, but here they're both the same. If I subtract 6y from each side, that's gone, and this is gone. So I've got 0 equals 19. Okay, so we got 0 equals 19. What is that telling us? It's not going to work. When the variable disappears, let me rewrite that so you can actually read it. When the variable disappears, there's two possibilities. The possibility we got here is we got something that is not true. 0 does not equal 19. And if that is the case, there's no solution. There are no numbers for x and y that I can put into these equations that'll make both of them equal or true at the same time. The other possibility is if I get something that is true, then just like when we graphed them, they're the same line. So that's an infinite many solutions. So let's see if we can come up with an example of that second one where there's an infinite number of solutions. So let's have 2x minus 3y equals 9. And (6y) equals negative 18 plus 4x. So when we go to solve these, we're going to solve one of them for x or y. Looking at them, there's only two possibilities. I can solve this one for x because it'd be dividing by 2. Or I can solve this one for x because it'd be dividing by 4. Which one's going to be simpler? Probably the 2, yes. We're going to solve that top equation for 2. What am I going to do first to solve that for x? Careful. There we go. It's a negative 3y, so we add 3y. So 2x equals 9 plus 3y. Then what? Divide by 2. So x equals, I'll help you along here, 9 divided by 2 is 4.5. Plus 3y divided by 2 is 1.5y. So we need to put that in up here for x in the other equation. So 6y equals a negative 18 plus 4 times, instead of x, I'm going to put in 4.5 plus 1.5y. Good. Now what do we need to do? Multiply. Perfect. We have 4 that we have to distribute through the parentheses. 4 times 4.5 is 18. Good. 4 times 1.5y is 6y. Now when we go to combine things here, we have negative 18 and positive 18 make what? 0. They cancel out. So we've got 6y equals 6y. I have a y on each side, a variable on each side, so I'm going to get rid of them. I subtract 6y, I've got 0 equals 0. Is that true? That is true. So what that means that these two are the same line. So that means I can go back and I can just name either equation as a solution. So any point that's on this equation is also on that line is also on this line. So just naming the equation as the solution would solve that system. Now there's one more method we're going to look at before we're done. I don't want to start it now because we only have about 5 minutes or so. But I do want to show you an example of why we would care about these system of equations. And we will go over more examples like this in the coming weeks, but I want to show you just so you're not doing generic algebra with no application for it. This is a roof of a house. It's actually what we would call a dual slope truss. And what it is it's popular on commercial buildings to have one slope steeper than the other. So this slope here, let's say that is a 16 and 12 slope. And this side over here, let's say that is a 4 and 12 slope. And let's say we know that the span of this building is 40 feet. I want to know where that peak is at. Now to do that, I'm actually going to define 3 variables here. I have x, which is the distance from the left end of the peak. I'm going to define y, which is the distance from the right end of the peak. And then I'm going to define h, which is the height. The reason I'm defining h is because h is going to allow us to convert x and y to the same variable. But if we look at what we know here, the easy equation to write is these two must add up to what? The 40-foot span. Good. That's the end of the easy part. Now we have to look at each side of this truss separately. So I'm going to look at that green triangle. I'm going to pull that down here. I know that this is a right angle, this height is h, and this is x. And this is a 16-12 slope. So that 16-12 slope is a rise over a run. So the rise here is h. The run here is the x. So 16 over 12 has to be proportional to h over x. Now we've solved proportions by cross multiplying and dividing. But before we did that, I showed you that one other way to solve proportions is just cross multiply. So going this way, 12 times h is 12h. Going this way, 16 times x is 16x. And those cross products have to be equal. What I'm going to do here is I'm going to solve for x by dividing by 16. So that's x. 12 divided by 16 is 3/4 h. So x is equal to 3/4 of h. I'm going to come back up here now, and we're going to look at the other side. We're going to look at this this triangle, I should say. We're going to pull this one down here to analyze it. The height of this is still h. The bottom of this is y. And the slope here is 412. Well, we know here that 412 slope has to equal the vertical, the rise is h, and the run is y. So just like we did over here, we're going to cross multiply. H times 12 is 12h. 4 times y is 4y, and those have to be equal. And once again, I'm going to solve for y. So I'm going to divide, or not going to solve for y. I'm going to solve for, I'm going to solve for y, sorry. Solve for y by dividing by 4, just like I solved for x over here. So I divide by 4, that's y. 12h divided by 4 is just 3h. So y equals 3h. Now remember, I have this first equation up here. X plus y equals 40. Well, I've solved here. X is equal to 3/4 h. Y is equal to 3h. So I'm actually going to do a double substitution. I'm replacing both of them with something that's in terms of the same variable. So now they're both h's. I'm going to combine them. 3/4 h and 3h is 3 3/4 h. Or if you prefer, you could do 3.75 h. And I have to divide by that 3 3/4, or 3.75. So h is going to equal 40 divided by 3.75 is 10 2/3 what that comes out to be. So h is 10 2/3. So now I can find x and y. X is equal to 3/4 h. So x equals 3/4 times 10 2/3. Well, 3/4 times the 10 2/3 has to become an improper fraction. 10 times 3 is 30, plus 2 is 32 over 3. If I multiply that out, 3 times 32 is 96. 4 times 3 is 12. 96 divided by 12 is 8. So x is 8 feet. Up here, y is 3 times h. I'm just going to reverse the order. So instead of h, I'm going to put in the 10 2/3. So again, that's going to be 3 times 32 over 3. This time I'm just going to cross cancel the 3's. That's 3 over 1. So y equals 32 feet. So back up in my original truss here, x is 8 feet and y is 32 feet. And they do add up to 40 feet. So I've located the center, the peak of that truss. Now again, we're going to do more examples of that, like that, in the coming weeks. But I wanted to show you that just so you're not sitting here doing generic algebra for weeks on end before we get to where we need to go. Okay, with that, do you guys have the quiz? Is Mr. Berghammer's not there today, I take it? You left the quiz for you guys to do? It's there? Perfect. Okay, so what I'm going to do is I'm going to let you guys have about a 3-minute break. Yep, they can work together on it as long as you're not copying answers. Okay. You too, thanks.